Hello everyone. Today we're going to look at polynomial functions, and particularly their graphs, and just three aspects of them: in behavior, x-intercepts, and y-intercepts. And I really want you guys to, this is an exploration lesson where you're going to have to try some stuff out on Desmos, so go ahead and open Desmos in another tab, or if you're watching this on a device, open it, be ready to switch over to that pretty quickly, okay? First of all, what is a polynomial function? We'll look at the equation side of it in a second, but it's a function that looks like this. The domain is always all reals, so you can plug in any number into a polynomial, there's no problem. And a lot of times there'll be kind of wavy lines like this going up and down, and they have these two. Every polynomial on either side will either get really, really large or really, really small, okay? Or really, really negative, I guess I should say. So for example, this purple polynomial here, we call this the end behavior, alright? You see here on the left how it's going in the negative direction on the left side, and it's going in the positive direction on the right side, okay? These are just kind of, they're exploding, going down and then up on the left and then right side. So that's the first thing we want to tackle with this. We want to see, okay, what makes something go up, down, or up, or down, down. Here's the red. Here's another example of a different polynomial function. And then here are two more examples on the right. Okay, so those are kind of the four possibilities. You can kind of down, up, down, up, or down, down. We need to be a little clear about using our language, though, because up and down, that could mean a lot of things. So I'd like for you guys to, for example, this red one, call this the left side is positive and the right side has negative end behavior. Okay. With the purple one, you'd say that the left side has negative end behavior and the right side has positive end behavior. Hopefully that's fairly intuitive to use, and then you could probably guess what the green and the orange are. But yeah, the green, you can say right and left are both positive, and then the orange, the right and the left are both have negative end behavior. Okay, so we're going to explore this in a second on Desmos, but first I want you guys to see how I would do this with parabolas. Okay, so I'm going to have you guys come up with your own rule, but let me just show you this example. Let's graph these two. These are just two functions I picked out because I'm trying to look for a rule for parabolas with end behavior. All right, so I'm going to plot it using the points, of course. And you notice the left and the right side, both ends here, are positive. Okay, and you can probably think about it for a second, and you realize, wait, with a parabola, they're always either both positive or both negative. Here on the right is an example of one where both end behaviors are negative. Okay, and so you could think about it for a second. And go, well, you know, the difference here, we have 0.5 on the left and negative 0.5 on the right. So my rule is that both ends are positive. The end behavior is positive if the coefficient, remember that's that word for the number in front, if the coefficient is positive. And then of course both ends are negative. The end behavior is negative if the coefficient is negative. Okay, so I came up with that real fast. It'll take you a little longer to come up with a more general one, but I want you to see if you can figure out, you know, of these four situations up here, when does each situation happen? Okay, when is the right negative and the left positive, for example? Okay, or when are they both positive? Okay, and we're talking about all polynomial functions. So let me give you a few examples here so you know what to try. Go ahead and try plugging these into Desmos just as an example. So x to the fifth minus 3x squared. These are polynomials because you have different powers, like x to the fifth and x to the second, and they're all added or subtracted together. Okay, simple as that. That's what a polynomial is. Here's another example. These coefficients in front, so negative 5, 20, and then 2 are all coefficients. They may make a difference. They may not. Okay, so I want you to play around with that, and in the box below here, you can't see it on the screen, but on that box down there, I want you, before coming to class, to write your own rule for when these four situations up here, when do they happen? Okay, so go ahead and pause the video here and try that out. Don't spend more than, say, 10 or 15 minutes on this activity. If you're stumped, come into class with at least a few ideas to help your group out, and yeah, we'll get a firm, fast rule hammered out when you come to class. Okay. Let's look now at the Y-intercepts. I think this one will be a little easier. If you're stumped by the last one, don't worry. So real quick, just a reminder, what is a Y-intercept? Well, it's where we hit the y-axis, okay? So in this situation, it would be 0, 2. I think it's really important that you guys write both the x and the y of the point, just to remind yourself what is 0. I think that's helpful. We often forget when we're doing that. So yeah, that's that point right there. And here's what I want you to do. I want you to play around in Desmos, type out, you could even type out these functions here, okay, and just test out some stuff and see if you can find out a rule, kind of like you did before, but this time it's for finding the y-intercepts, okay, and I want you to write this in here before coming to class, alright, just like you did the last rule. You can also answer this question here. Why is the last one a very helpful example? Okay, that I'm talking about this third function here should be the most helpful of those three functions. And yeah, feel free to use your own functions, okay? Yeah, so go ahead, pause the video, and let's do that right now, okay? Alright, hopefully you found a good rule for the y-intercepts. Just a little trickier is the x-intercepts, alright? Just a reminder what those are. Those are the x-intercept, sometimes we call them zeros, alright, but they are the points that hit the x-axis. So for example here we have three of them, -6, 0, 0, 0, and 8, 0, okay. Again, this is just a random example I drew. You might want to try these three other examples right here in Desmos, alright, and again, I think the last one is a very helpful example. So go ahead and see if you can write a rule before coming to class for finding the x-intercepts. And once you do that, that's the whole video. Hopefully this activity did not take too long, and yeah, look forward to seeing what you guys have in class. Thanks.